Hi, my name is Doug Schneider. Welcome back to Real Hi-Fi, where today, for the 100th episode, I want to take you on the road again to where we went in the spring, to Rotterdam, in the Netherlands, home of Dutch & Dutch, maker of the famous 8C loudspeaker. It was there that I talked to Martijn Mensink, the lead designer, about some special features that loudspeaker has. So we're here with the world-famous 8C loudspeaker from Dutch & Dutch, and it has what you like to call 3 room-friendly acoustic features. Can we go through them from the high frequencies to the low frequencies? And let's start with the tweeter.
Absolutely. So what we have here is a dome tweeter, a metal dome tweeter in a very big waveguide. And what this tweeter and the waveguide do is they control the directivity of the loudspeaker.
The waveguide does, because the tweeter alone would do what?
The tweeter alone, in like any conventional speaker with a flat baffle, would have at the lower frequencies of its passband. So a very normal frequency for a crossover is say 2,000-3,000 hertz. Around that frequency, it would radiate quite widely.
Okay.
Very wide.
At lower frequencies of it, of what it's reproducing.
Yeah. So most tweeters would reproduce the bandwidth between about say 2,000-3,000 hertz and 20,000 hertz.
Mm-hmm.
And in the lower end of the passband, it would have a very wide dispersion. And the higher you go up in frequency, the narrower it becomes. The purpose of this waveguide is to ensure constant directivity. Now, what does constant directivity mean? The tweeter has basically the same amount of directivity at lower frequencies. So this one in particular, it takes over at 1250 hertz.
Very low crossover frequency.
It's a very low crossover frequency, which this tweeter can handle. And the waveguide helps because it adds a bit of sensitivity.
So it not only controls the dispersion, but acoustic gain it provides.
Absolutely, yes. Yeah. So it increases the dynamic range of the tweeter.
Okay.
So what this tweeter does in this waveguide is it basically acts as sort of an acoustic spotlight. So it focuses the sound in a reasonably wide area,
okay,
but constantly across the entire frequency range. So all the way from 1250 hertz up to 20,000 hertz, it's a constant beam.
And so below 1250 hertz, we move to the mid-range, where I assume the waveguide matches the dispersion characteristics of the...
Exactly. That is vital.
But there's more here. Yeah. It's cardioid.
It's cardioid.
Can you explain that?
Yeah. So if you have a conventional mid-range driver in a conventional box, say this were a closed box, what you get is at the higher end of the passband, so in this case it's 1250 hertz, the directivity would be determined by the size of the membrane and basically the size of the front baffle. So the size of the mid-range and the diffraction effects that occur at the edges of the baffle, that together would create a certain amount of directivity.
Okay.
And the directivity that this driver has at the crossover point is the same as the tweeters with the waveguide.
Nice smooth dispersion on and off axis.
At that frequency, yes.
Yes.
But say this were a normal mid-range in a normal enclosure. At that frequency, it would behave the same, so at 1250 hertz. But as you go lower and lower in frequency, what happens is the wavelengths become longer and longer and longer. As the wavelengths become larger than the size of the enclosure itself, what happens is that the sound waves will wrap around the enclosure, and it will no longer be directional. What will happen is the sound wave goes in all directions, basically.
Okay.
So at lower frequencies, so we're talking about the lower hundreds, about the same amount of energy goes to the back,
okay,
as to the front.
Okay.
And this is something we do not want.
Okay.
And this is where the cardioid comes in.
Okay.
So what we're doing in this enclosure, you might see here, there's a vent here on this side of the speaker, and there's another one here at the other side of the speaker.
Symmetrical?
Symmetrical, yes. And what we're doing here, the mid driver, the mid woofer, it moves forwards and backwards. As it moves forwards, it pushes against the air molecules, so it compresses them.
Okay.
And the result of that is that the air pressure increases.
Okay.
At the same time, as it moves forwards, there's rarefaction in the back, so the sound pressure goes down.
You're talking behind the mid-range driver itself.
Inside the enclosure.
Okay.
So kind of what happens is the pressure on both sides of the membrane do this.
Okay.
What we're doing here with the vents on the sides, we're using that out-of-phase sound that is...
Out of phase being the opposite.
The opposite phase, that's right.
Yeah.
So the sound that is radiated inside the enclosure, usually it's a problem. In conventional speakers, you have to get rid of that energy.
Damping and stuff like that.
Exactly.
Yeah.
And you have to brace the cabinet and make sure that none of the sound comes out, like as delayed resonances through the panels, etc. In this case, what we're doing here is we're actually using that energy to form a cardioid.
It's coming out of the cabinet.
It's coming out of the cabinet through these vents.
Mm-hmm.
And because the sound is in anti-phase, perhaps you can imagine that if there's one high pressure, one low pressure, and you combine them, they can cancel each other. And this is what we're using.
So you're getting a cancellation on both sides.
Exactly, that's right.
Okay.
So what happens is the sound from the front wraps around the enclosure as it does with a conventional speaker. Normally, the sound would unimpeded go in that direction. But what happens here is the sound is radiated on the front, wraps around the baffle's edges, and as it reaches these slots here on the side, it cancels. So there's no sound going in that direction.
Okay.
And now the magic is the combination of all this. So at the high frequencies, we have the tweeter, the phone tweeter on the waveguide with a constant beam width. Then the mid-range driver takes over. At the higher end of its passband, because of the size of the membrane and the edge diffraction at the edges of the baffle.
All the rounding and all that sort of thing.
Exactly.
Yeah.
That ensures that at the higher end of its passband, so we're talking 1000 hertz, 1250 hertz, the directivity is determined by the size of the membrane and the edge diffraction. You still get that constant beam width at those frequencies. As we go down in frequency, a conventional loudspeaker, the sound will wrap all around, and you get a lot of reflections up the front wall, up the side wall, the floor, the ceiling, etc. This speaker doesn't do that.
They're reduced.
They're much reduced. That's right. Because we're canceling the sound that goes in unwanted directions. And all that's left is a constant beam width to the front. And this goes all the way down to 100 hertz.
And so that's 2 out of 3 things. There's one more thing.
There's one more.
Probably the least understood about this speaker, and that's the rear-mounted woofers. Makes it a 3-way design. They're working together, but explain why they're rear-mounted and what the wall behind the speaker has to do with that.
Yeah. So these two woofers, they go all the way down from 100 to 20 hertz.
Okay.
That makes the Dutch & Dutch AC a full-range loudspeaker.
Because 20 hertz is the lowest part of the audio band.
Pretty much as low as it goes.
Yeah.
So this is a full-range loudspeaker. These two woofers have a large excursion capability, so they can move a lot of air, which means that they can play at quite a loud level at those lower frequencies. And what is special about them is that they're positioned in the rear of the cabinet, as you said. And this speaker is designed to be placed relatively close to the front wall.
How close is close?
Convenient. 5-10 centimeters is fine.
So
up to about 50 centimeters is ideal. Beyond that, it's slightly less good.
So 1.5 feet to down to a few inches.
Yeah.
Or a couple inches. Yeah. Okay.
Yeah. So what we're doing, we're using something that's called boundary effect.
Okay.
What basically happens, because the woofers are relatively close to the front wall, and at low frequencies, the wavelengths are very long. So we're talking 3.4 meters up to about 17 meters.
Okay.
So they're way longer than the distance between the woofers and the wall.
Many times the size of the cabinet itself.
That
they're
too.
very long, yes.
Yes. And what happens because of that is the woofers acoustically couple with the wall. What that means is basically the wall and the loudspeaker, they become a single system.
They're working together.
They're working together.
They're pushing into the wall, figuratively, the air, and then using the wall.
The wall pushes as hard back as the woofers push against the wall, in a sense.
Okay.
The wall, in a sense, becomes a part of the loudspeaker itself.
And that increases bass output and makes also, I think you've said to me in the past, a coherent wave launch. What does that mean?
Yeah, so it augments the bass by 6 decibels, so you get twice the output.
Okay.
So that's a big advantage. And the second thing is that because the woofers are so close to the wall and they work together with the wall, the combination of the wall and the speaker produces a phase coherent wavefront.
Yeah.
And the benefit of that is tighter bass, and it just sounds quicker, and it's easier to hear the precise notes.
So the waveguide, the cardioid, and the woofers close to the wall. The 3 things that make it more room-friendly than most loudspeakers.
Exactly. Those are the acoustic innovations that we employed in the Dutch & Dutch HC. Then on top, there is the DSP, with which we can do setup adaptations. We can tell the loudspeaker how far it is from the boundaries. We can make adjustments to its behavior. And also we can do room equalization with dedicated software.
For room modes and bass problems and that sort of
so
thing.
you have to measure the response in your particular room, and we can make adjustments based on the measurements to make sure that the Dutch and Dutch HCs adapt to the acoustics of your room so that you get the best sound.
Like I've said in the past, a well thought out speaker design. Great job. Thank you.
Thank you.
So one of the takeaways from this should be never look at a loudspeaker in isolation. How it interacts with the room is what matters the most, and it's here that Dutch and Dutch nailed it with the 8C. Now, why do I say that? First, the speaker sounds fantastic. I love it. But also, it has a track record, longevity, and widespread acclaim. It was released about 7 years ago, and to date, it's still the company's only product. But that might change in the future. I hope you like this content. Thank you for watching.